Hey, good for you. Good for you. Oh, yeah. Chloe is missing today. Oh my gosh, where's Chloe? All right, so let's do this little electric charges. All right, so I've got all right, so start a poll. This says poll one. There's A and B on this one. All right, so we got to wait and see. So this is unlike charges. Okay, let's see what the answer is, and you pick which one of the answer. Hey, there's Chloe. Good to see you, Chloe. Attract or repel? If unlike charges, attract or repel. All right. Hey, look at that. 4 out of 4. Nice. And you guys, most of you guys said attract. All right. And come on. And that's correct. So plus and minuses. So plus and minus attract each other. So this is the next poll. Publish a poll. Start a poll. This is like charges. What did like charges do? All right. Let's wait a minute until we get the answers up there. Like charges. So plus and plus. What do you think they do? Do they attract or repel? So positive and positive, negative and negative. Hi, Grace. What did you guys say? All right, so unlike charges like plus and minus attract, and like charges, what do they do? They repel. That's what you guys got. And yep, most of you guys got repel. So like charges like plus and plus or minus and minus. This is the next one here. Publish a poll, start a poll. This has 4 answers to it because if you have 8 electrons, 8 protons, and 10 electrons, what do you get as far as the charge on that? Okay, so what is the charge if you have 8 protons, 8 plus charges, and 10 negative charges? What do you get? Do you get plus 18, plus 2, plus minus 2, minus 18? Hey, Madeline, get in there. Kylie, get in there. DeAndre, Adriana, good to see you guys. Come on, put this down here. What do you think? It's going to be A, B, or C, or D. A, B, C, or D. Thanks, DeAndre. So most of you guys had said letter B, and some of you, so it's 8 plus charges and 10 negative charges. So this is going to be a negative charge. Okay, so you have 2 extra electrons, 2 extra electrons. All right, so how about 8 and 8? 8 and 8. Publish a poll. This one, start a poll. This is actually poll 4, but I have to put poll 5. So if you got 8 protons, 8 positive charges, 8 negative charges, remember they cancel each other out. So they cancel each other out. So what will this be as far as a charge? Oh, wow. Good check on that, Grace. All right. Thanks, Rachel. Chloe. Kylie, thanks. So 8 plus and 8 minus. So every one of those cancel each other out. So you should have put down A. Okay, letter A. 8 protons, 8 electrons. So today what we're doing, we're talking about electricity. And electricity is current flowing, right? Flowing of electrical energy is called electricity. I did not go through all the, didn't go all the way through. So there's a lot of vocabulary in here. And the vocabulary, again, use your notes, right? So with metal conductors, electrons are free to move where they want to, right? Electrons can move between atoms, and electric current is the movement of atoms here. So what happens is negative electrons move from atom to atom, and they just bump each other. So what's common misconception is that when you turn on a light switch, that the electric electron that you pushed up has to go all the way to the light bulb. Well, because there's so many electrons in order all the way to the light bulb, it just nudges one and then the other one, they all get nudged, and it really moves very fast. So electrons push each other along, causing electric current to move. All right, so this is our current electricity. The flowing of electrical energy it's called electricity. It's called this because the flow of charges is called current. When charges move, they carry electrical energy or electricity with them. Electricity is used for power. All right, now static electricity, I made a static electric motor a long time ago, but I needed to get it charged by a television. Like the television static would make it go. It didn't move very well, but every time I got it close to the television at the time, it would give it a little static charge. So we have to produce electricity. What we talked about last week was electromagnetic radiation. If we can get the induction of a magnetic field and make that happen, push a magnet in and out of a coil of wires, we can get some electricity to flow. But we got to do that. Hey, Dylan, good to see you. So which of these, right, so let me go here. Which of these is electricity? Is electricity the physical property of a particle that causes it to be attracted to nearby opposite charges, or is it a form of energy resulting from charged particles? Which is it, A or B? All right, so I got 2 people, 3 people. All right. All right, so it is, so we're 50-50 chance here. So it is letter B, a form of energy resulting from charged particles. So, and we can do this, we can get at by creating power sources. So we're going to be talking about circuits today. Specifically, we're going to talk about building series circuits and parallel circuits, so 2 of them. A circuit is a loop where the flow of electricity. So think about the race circuit. A race circuit goes around in a circle. Okay, so this is what a circle is, or what a circuit is. It's a loop. It consists of a power source like a battery or plugging into the wall, wire, okay, we need a conductor, and an electrical device like a light bulb. Okay, so the power sources push the current, so the battery pushes the current. The wire connecting the devices provides the pathway, and then the electrical devices use the electrical energy. So a light bulb is an electrical device, and if you have, my grandson has this little circuit maker where you can put these wires together. They actually just plug in and so forth, and you can put different things like a buzzer or music maker. Those are your electrical devices. Radio, okay? So electrons flow along a path, and sometimes we use this path is called, so this path is called what? A source of electrons, a path of electrons, something to use the electrons, or a circuit. So it's a short word. So that means that it goes in a path like a circle, like a racetrack. Horses or speed, or, Daytona 500. Thanks, Adriana. Anybody else got that A, B, C, or D? Thanks, DeAndre. Rachel, thank you much. How about you, Cassidy, Grace, Dylan, Chloe? All right. Okay, so, all right, so this is letter D. Most of you guys got that? Letter D, a circuit. A circuit is what we've been talking about here. Now, let's go back to creating our circuit. All right, so we have to look at getting a source of power. A battery is a device that creates and stores energy, because I got a lot of those. A lot of times I got a whole box of batteries that I haven't used yet, and I get the ones that say they'll last for 5 or 10 years. They use chemical reactions inside them, and where there's excess of electrons down here in the negative side, and they, again, like negative and positive, they want to attract each other. So because they're split up into pieces here, so they're all the electrons are down here, then this gives a potential difference and makes that 1.5 volt battery, right? Which we've been stuck with for forever. Now we have some new ones that are 3 volts, but in my day, you could peel the wrapper off the battery and get into the chemicals that are in there, which was not a good idea, but we could do that. Nowadays, they're made of metal and they're goopy inside. And, the only advice I would give to you guys is if you have a device that uses a battery and you're not using it, take the batteries out, because they start to corrode the inside of your electronic device and it can ruin it. All right, so the battery generates electricity by pushing the current through the circuit. The battery has a positive terminal called the cathode, a negative terminal called the anode, and the electrolytes are the stuff inside that creates the energy, and usually goes from negative to positive. The electrons want to go toward the positive. All right, so what is the part of the circuit is responsible for pushing the charges along? Is it the electrical device like the light bulb? Is it the wire that pushes electricity? Is it the power source such as the battery? Or is it none of these? So it's not none of these. It's either A, B, C. All right, which one of those is it? All right. Yeah, thank you guys. DeAndre, thanks so much. Such a nice guy to get in there and get that. Thanks, Dylan. Thanks, Chloe. All right, so this is, most of you guys have it, right? What pushes it in, so what we just talked about was the power source, so the battery. That is the pusher. The electric wire just kind of conveys that, so, right? So the flow of electricity has a circuit, right? And we usually put devices in there. So we have a battery. Sometimes we have a switch where we can turn it on and off, a little button maybe. So we can turn this on and off, or a switch that goes back and forth. And on a wire, so because the light, you don't want the light bulb on all the time. So, and then electricity goes from the negative side, and these, if you have a small light bulb or an LED, it crosses a path and creates a light. And normally what the light bulb was that it slows down here, creates heat to have light. All right, so that's what it does. It goes through here. So these are connected, right? And an LED doesn't create, it creates mostly light, doesn't create a lot of heat. And then, but it does create the path here. So negative, so this is a complete path of the flow, goes through here. Switch, you can turn it off, and that breaks the wire in there, or basically keeps, has a connection between the wires, is a switch, right? Now batteries, like that we said, would create and store. Here, a capacitor only stores energy, right? They're separated by insulating material, the charges are, and it holds a positive charge and negative charges, right? And the force between those, due to the opposing charge, will hold the charges in place until a conductive path is provided. So it allows the charge to flow away. So it does not create electricity, but it stores it. So you can turn on a battery, and then the capacitor will store it until it's needed to be used. Now, what they use it for storing electricity, they allow certain currents to pass while blocking others, and they can filter out electrical noise. usually they're being used for lots of different reasons nowadays. I've even seen some electric buses that use large capacitors to store the energy for the initial push of the most energy it takes to start a vehicle to moving it from stop. That's where they're using these capacitors along with batteries. So they let it store up a lot of power, use it to get the bus going, and once the bus is going, then the electricity can flow freely. So it's one of the ideas that you can use for capacitors these days for electrical engines. So we talked about batteries and we talked about capacitors. So did I say a capacitor creates and stores energy and a battery only stores energy? Did I say a battery stores energy and a capacitor creates energy? Did I say a battery creates and stores energy, capacitor only stores energy? Or a battery and capacitor are different names? So that's not true there. That's not true. So either A, B, or C. All right, and we know that a battery creates and stores energy, and a capacitor is the new thing. We usually know that because we have the batteries and we put them in the drawer and we use them when our mouse dies. A capacitor only stores energy. So it's letter C. All right, letter C. All right, thanks, guys. Thanks, Carmen, for getting in here today. I appreciate you guys doing that. Participation here. So electromotive force is the force produced by a potential difference in a circuit and causes the charges to move. So current is that flow of electricity. And you can see this is a large current, trying to give you a picture of that. A lot of electrons moving, right? And then a small current, a few electrons moving, right? So if you get too many, so that's the case. If you get too many going at once, you can actually burn up your wires. So that can be a dangerous thing. Who came in? Let's see. Ken came in. Hi, Ken. Good to see you. So the flow of current. Now, here's the weird thing, and there's a question on the test. Conventional current is by convention, means that a bunch of people got together and decided, hey, we're going to say that electricity flows from positive to negative. Okay, really doesn't do that. Positive to negative it's really negative to positive. And the reason I say that is because they were starting to wire light bulbs up and so forth with electrical batteries before they knew which way it went. So by convention, they said, we've been talking about positive charges moving from the positive terminal to the negative terminal, and we've always written it that way. What else did we get in here? John Nutter, yeah, good to see you. Excellent. A little bit late, but never too late. So a closed circuit is where there's a continuous loop, okay? Continuous loop. So the negative goes through the light bulb, goes through the other light bulb, and comes to the positive charge. That's a closed circuit. If for some reason I put two positive charges here, okay, and got rid of this, that would be an open circuit, right? So that would not be a good thing. That means you wouldn't light it up. When we did these things in elementary school and also in middle school, we gave people light bulbs and batteries and say make it light. And so they had to figure it out on their own to make a circuit closed path. Okay, so circuits cannot have breaks in them. They are continuous. Was that an open or closed that I just talked about? Closed path or an open path? What was that? Thanks, Rachel. Thanks, Chloe. All right. Thanks, John. All right. Anybody else? Okay. And most of you guys are saying open. An open circuit is got a break in it. Okay. This is a closed circuit. Closed circuit is where it's like nobody else can get in, I guess. Open could be the path is broken, right? So let's take a look at what an open circuit looks like. See, here is just, we need a path from the power source and from negative and positive, and it has to go through these. So here is no positive, it's only positive, so we're not getting any electrons flowing here, just one wire here, right? That's an open circuit. Right here is an open circuit, two positives here. You need the negative. Here is an open circuit because there's no wire between here and here. Come on, I'm drawing. No wire between here and here. And we need this to be here. Get rid of this wire here and put it to the battery. How many people have tested out a 9-volt battery with your tongue? Have you anybody done that? To put a 9-volt battery on your tongue? Anybody do that? And it tingles. And I can feel it right now. All I have to do is stick my tongue out and think I have a battery on there. Yeah, so if it doesn't tingle, then you go, this is dead. This is a dead one, right? The 1-volt battery, it's really hard to do that because you'd need to have your tongue cut in half, and then you could get on either side, right? But the 9-volt battery, both positive and negatives are on the one end. So and that because you got a water and you got like a liquid in your mouth, and that connects pretty well, right? All right, so we can have this switch in here. Some things have an open. So this is an open with a switch because the switch closes to let this through. So this is a closed circuit. This is an open circuit, right? Light bulbs come on. Okay, so what we're going to do is we're going to make, and we're going to experiment with a PhET assignment here. Let me give this for you guys. You can do this with me. All right, so here is the assignment for today. It's worth 20 points. So if we can do this, probably do this in about 5 minutes. Okay, I'm going to give you this link. This is 5.14 exit, and this is on series circuits and parallel circuits. So there are two names you have to remember. And again, they are, let me give you this. Here we go. All right, so let me give you what we're going to do here. So we are going to look at this link here. Okay, so in this assignment, let me turn this off here. In this assignment, you have a Google Doc. You're going to take a picture of a parallel and a series circuit. Now, I can tell you what a series circuit is. And first off, I want you to do is I'm going to click this and get this started. Okay, so we're going to use this PhET assignment. We're going to hit the intro. And we're going to make a series. Now, a series, think about a series as like a series of books. The cat that came to breakfast, the cat that, all right, so you may have them in order. They may be by publishing date, and you read them in order. Okay, so light bulbs are series circuit is like reading the books in order. Could be all the Star Wars books, or it could be all the Harry Potter books, all in the same order. Okay, so what we got to do, and if you are doing this with me, you're going to have to take a picture of your series circuit. So what we're going to do is we're going to take a piece. We're going to take, first of all, we're going to take 3 light bulbs. 1, 2, 3. All right, and tell me if I'm going too fast. Tell me to slow down. Got 3 light bulbs. I dragged them on here, and I'm going to have the wire go straight through it. So I'm going to put this conducting wire here, and then the upper circle I'm going to connect to the bottom, the lower circle on the lamp, and then I'm going to connect the upper circle with the lower circle. Okay. Now I'm going to take a light electrical bulb wire and move it down here so I can connect a battery to it. Okay, so I've got the path goes from the battery. So we're going to put a battery in here. Goes from one light bulb to the next light bulb to the next light bulb. Okay. Right. So, and then we take our power source and we're going to plug it in here. So I'm going to put a wire from here to here, and I'm going to put a switch in from here to there. Okay, and I can drag these. So how many people have this set up just like that? Tell me if you've got it set up or you need more time. Because you're going to need to take a picture of this. Right? This is called, can I have labels? Can I type anything in here? All right, so this is called a series circuit. SER. Can I do that? No, I bet you I can't. No, I can't. Won't let me do it. Need more time. Okay, 3 light bulbs, and then 2 wire, and wire, and I've got a switch. All right. So tell me when you're ready, Rachel, and I'll move on to this. So there are other components that you can get on this. If you want to fool around with this, you can put a fuse in it. You can put a dollar bill. You can put a coin, put a pencil, eraser. So lots of different things in here. So this is kind of fun to play with. All right, ready. Okay, so when I flip the switch, I just have to click this and notice that the power is going from the negative through all these lights. Okay. Now, so you're going to take a picture of this, and then you're going to submit this as your series circuit. Light bulbs going through each other. And they have a question in there, is what happens if one of the light bulbs goes out? So I'm going to turn off, I'm going to click on this, and there is a pair of scissors. Click on that, and I cut the wire. Okay, now it's an open circuit. What happens? So this is like your Christmas lights with a light bulb burning out. And these are the early Christmas lights that I used to have. They were always series circuits. So one light bulb was connected to another. That's the easiest way to do things. Just put one light bulb onto the next, onto the next, onto the next. And if one burns out, they all burn out. They're all out. Okay. Or if there's a wire broken, they're all out. Okay, now I connect it, and I do the same thing if I can disconnect this one. Okay, it burns that. They're all not working, right? And when they're all out, it's sure hard to tell which one is the bad one, right? So that's what a series circuit does. And notice the light bulb light. Okay, so what I'm going to do is I'm going to show you something. I'm going to cut this one here, and cut this out there. And I'm just going to connect this. Notice that these are brighter now. All right, so when I put light bulbs together in a series, they all get dimmer. So the more I put in, the dimmer they get. The less I put in, so if I cut this one, cut, okay, and then just plug this one in, look how much brighter that one is on one light bulb. Two light bulbs was not as bright, gets less and less. All right, so that's your series circuit. Any question on that? Were you able to take your picture and answer that question? What happens when you take a burnout light bulb? So I'm waiting for people to say yes in the chat. Oh, Rachel said, yeah, all right. Okay, so I'm going to hit the reset button. Now we're going to do a parallel circuit. Okay, a parallel circuit looks like this. Take our 3 light bulbs, put them up underneath each other, okay? Now what we're going to do is we're going to connect a wire on each side of this. So we have multiple paths. This is a parallel circuit. Having wires, it's a little more complicated when you make these. These are the kind of Christmas lights that you want to have where they have parallel circuits. Okay, so you got 3 sets, you got wires coming out, and now what you do is you take another wire and you connect it sideways here. So it's a little more complicated to do when you, and probably more expensive to buy light bulbs for Christmas lights like this that are in parallel. Right, so I'm kind of constructing it so this is multiple paths, and now I'm going to put my battery down here. Okay, put my battery down here. I'm going to put my switch. Let's see, my battery here and my switch here. Okay, did I get them all? Okay, so I'll give you a minute or so to get that together. Tell me when you're done. All right, and then we'll throw the switch on this thing. So the the power can go through this first light bulb and come straight through. If that one goes out, it still has path to go to the second one and go all the way through. And if that one goes out, it still has a path to go to the third one and always go through. You can see it's a little bit more complicated wiring for parallel, in parallel, right? Anybody need more time on this one? DeAndre had to take the dogs out. So let's throw the switch on this. There we go. Uh-oh, I did not connect this. Let's see how I got it. There we go. Notice the electricity or the battery, the flow is a lot faster. The lights are a lot brighter and they're all the same brightness. Okay. So parallel, it doesn't matter if you have one light. So if I just disconnected this one, the brightness didn't change. The lights didn't go out. If I disconnect this one, I still have the same, I have one light bulb still working. And when I connect it, see the light bulbs don't dim either. So like with the series circuit, you take a light bulb out, put more light bulbs in. You can't take a light bulb out. But if you put more light bulbs in, they get dimmer and dimmer and dimmer. Where the parallel circuit, you can certainly tell which one of these is broken because it's out. The other ones are still working. So if you have to fix a light in your parallel, you know that one's burned out and the other ones are still working. So parallel, you get to have the same kind of brightness. The brightness is the same. Doesn't matter. It'll use your power up sooner if you're using it on batteries, but it's much easier to fix. Okay, much easier to fix because you know which one's burned out. On the series circuit, you don't know which. They're all out, so they all look like they're burned out. So, all right, how'd you guys do? Do all right on that assignment? Anybody needs any help on that? All good here. Okay, so let's take a look at the assignment what we talked about today, just kind of in review. So a series circuit, they're all linked in a row, one after another. The circuit is set up with the devices way it's called a series, like Christmas lights, in a series like a series of books. You read them in order. Okay, this two in a series, they go through each other. You burn one of these out. If this burns out, that means this one goes off. So I don't know if it's burned out, but this one goes off. Everything goes out, right? And this is a diagram, electrical diagram of a series circuit. You can see this is the battery down here. The battery, power And then these are the light bulbs, light bulb 1, light bulb 2, and light bulb 3. You can see they go through each other. So if one burns out, the other ones go out as well. Now, a parallel circuit is like we saw. We have more than one path, separate loops. You have a loop here and a loop here. Right? So if this burns out, this stays bright. Okay, and the brightness are all the same. Even if this burns out, the brightness will not get any better. Okay, so here is a series circuit that you guys made. Now here's a diagram of a series circuit because it has more than one loop. It has one loop here and one loop there. But interesting enough, this one right here is a series circuit in between, because if this one burns out, it's going to take this one with it. But we can still have the loop going around. So that's why this is kind of interesting. It's a little bit different. It's kind of a combination. So parallel. All right, so let me ask you this question here. So let's go and ask this question just as our end of class here. So A or B, is this a parallel or series? So circuit, C-I-R-C-U-I-T. All right, which is it? Is this a series circuit or a parallel circuit? What do you think from what we just talked about? Are there multiple loops? Okay, so here's the battery. Are there multiple loops? Can you go through this way and through that way? If you can, it's called a parallel circuit. If you can only go one path, then that would be a series circuit. So this is your parallel circuit, right? All right, so 3 light bulbs linked in a series, one goes out, it's no longer a closed circuit, it's opened, so it becomes, so they burn, you can't see those. Series circuit, parallel circuit, one blows out, still a complete path. All right, so there we go, ladies and gentlemen. Thanks so much for participating. And only thing I'd like to say here, right, is use your notes if you're doing assignment 1, right? Do assignment 1 because there's things that we haven't talked about yet. We will go over those on Friday. So we'll be talking more about voltage, ohms, and resistance, more vocabulary for those electronics majors here. Anybody think that they would like to get into making computers and components and things like that? Anybody interested in that kind of stuff? It's quiet here, so that means nobody's interested in making electrical components. There used to be a whole bunch of people used to make electronic components when they first came out. Now they're so cheap that people don't do them anymore. But so what I'd like you guys to do today is to try W16 assignment 1. Try to do that. If you are interested in just passing the class, just passing, right? That means you're going to pass with a D, and that's what you're comfortable with. And you have, let's say you have a 10% in my class. We still have time to get that grade up. All right, so see me in the big blue button. I'll give you that link. Right, and I'll tell you a shortcut way to get your grade up to a D. Now, if you're the B and A range, the things that you want to focus on is any assignment that says let's say W2, and it's assignment 1, and it says 9 out of 12, 9 out of 15. Fix that, right? 9 out of 15, fix that. Make it 15 out of 15. That'll make sure your grade goes up. Every point counts because they're all about the same. All right, ladies and gentlemen, I'll let you guys, I'm going to stop talking here, put this on pause.